Good morning, everyone, and welcome to Rice Talks, the Environment. With the ongoing efforts to combat climate change and take seriously environmental issues and environmental justice, Rice understands that this is a cross-disciplinary conversation that we need to be having. So today we are super lucky to be joined by professors from the humanities, from the social sciences, from earth science. And first up we have Sylvia Dee. She is an assistant professor of Earth, Environmental, and Planetary Sciences here at Rice. Her research combines climate information from the past and present to improve predictions of future climate. So welcome, Sylvia.
So as Kate mentioned, I'm a climate scientist, and one of the main messages I give all of the people that I work with is that the science of climate change is very simple, the impacts are serious, but the problem is solvable. So I thought I'd start out just by talking through some of the simple science of climate change. And we're very, very lucky, as I hope you all know, to live on Earth, which happens to be in what we call the Goldilocks zone in planetary science. We're far enough from the sun for water to condense into liquid, and we're close enough to the sun for water not to be frozen all of the time, like our sister planet Mars. And really, we're in this very narrow habitable window where life can survive. And our atmosphere is a big part of it. Earth's atmosphere has been in a very delicate balance for millions of years. And right now, as I'm sure you all know, we're altering the chemistry of the atmosphere by increasing the amount of greenhouse gases that are in the atmosphere naturally. So as we add more compounds such as carbon dioxide and methane, essentially we're creating a thicker blanket around the planet and warming up the atmosphere. CO2 and methane both absorb outgoing long-wave radiation from Earth's surface, trapping more heat. So as we increase the concentrations over time, the planet has been warming. And this is very clear in data from weather stations, for example, and in more recent times, satellite observations. These maps each show 1 year from 1850 to today of temperature anomalies on Earth. And as you can see, the planet has been steadily warming with a rapid acceleration of that warming, especially over the last 3 decades. This is not surprising. We know that we have been increasing the carbon load of the atmosphere. This is the total global fossil carbon emissions, which amount to about 6.5 gigatons of carbon per year. And so, as I mentioned, those compounds in the atmosphere are increasing the amount of heat or radiation that the atmosphere retains. We can put that in a unit of watts per meter squared. So I'm sure you've all installed a 60-watt light bulb, so you know the units of watts. So 3 watts might not sound like very much, but if you've ever installed Christmas lights, 3 watts might be about the amount of light that a Christmas tree would put out. However, if we add up 3 watts per meter squared over the entire surface of the planet, it adds up to the amount of energy released by 4 nuclear explosions per second. So my key message to you about the science is that humans are doing quite a lot to alter the global climate system. And really, the science is quite simple. As we're all familiar by now, in the United States especially, the impacts of climate change are very serious. I gave a talk just a few days ago when Hurricane Delta was barreling towards Louisiana, and now unfortunately we have yet another hurricane about to hit the Louisiana coast. We have really skirted by in Houston with a lot of luck this hurricane season, but obviously our luck could run out. Texas has already experienced 55 major flood-related disasters since 1978. The rainfall amounts are increasing. For those of you who were here in Houston for Hurricane Harvey, Harvey really shattered the record in terms of rainfall accumulation. I'm not really sure why this gentleman is smiling, because Harvey cost the city of Houston $125 billion and counting. And as a climate scientist, what we want to know is how are these trends changing over time? So these graphs show the total number of water-related billion-dollar events and their cost over time from the National Oceanic and Atmospheric Administration. So just looking at these plots, the blue lines again are showing the total number of billion-dollar flooding events per year. These events are increasing in frequency and they are costing us more money. This is predictable. We know that as we warm up the atmosphere, it can store more water vapor, and thus the top 1% of precipitation events are likely to increase in a warmer climate. we are already seeing these impacts of climate change on the hydrological cycle. They are upon us. On the flip side, we also know that increasing temperatures will stress our communities. Depending on how much greenhouse gas forcing the planet undertakes, in a low forcing scenario versus a high forcing scenario, when I say forcing, I mean carbon dioxide forcing, the change in the number of days where Texas experiences temperatures over 100 is likely to change dramatically. And in some cases, we're looking at 1 to 3 months of additional days per year over 100 degrees. These impacts obviously have, these effects have large impacts on, for example, people who work outdoors. So suffice it to say, given the fact that we have these very stark impacts due to climate change, what I want to know in my job is how much worse will these disasters become? Answering this question is not trivial. Unlike our partner scientists in chemistry or biology, we don't have an extra Earth that we can put in a test tube. So right now, we're running an active experiment on the planet. And unfortunately, we're seeing how these changes are manifesting now. Part of what I do in my job to get around this problem is I use climate models. So climate models are our best substitute for a test tube Earth, and they provide our only means for predicting future climate change. We can run our climate models into the future to try to understand how human interaction with the atmosphere is changing the climate system. This is a short video which shows changes in temperature through the 21st century as simulated by a climate model. You see a few key features, including amplified warming in the Arctic, for example. And when we add up these temperature changes all together, we can see how much global temperature change is projected for the future. And unsurprisingly, climate models predict warming. This warming depends on how much carbon we put into the atmosphere. So each one of these colored lines, for example, shows the temperature anomaly we can expect on a global average, depending on human behavior. This ranges from 1.5 degrees, which many climate scientists consider safe warming, all the way up to 4.5 degrees with a business as usual, we don't change our behavior scenario. And 4.5 degrees makes most of the tropics uninhabitable and would force massive migrations of people out of the tropics and subtropics. So these are serious considerations that we have to make. My research specifically focuses on the impacts of warming on extreme flooding in the United States. More recently, I've been focused on the Mississippi River Basin, which has experienced historic floods, especially over the last decade. They've caused billions of dollars in damage and caused catastrophic effects for the people who live in these areas. So we're motivated to try and understand the climate drivers of these major floods. This is a Landsat, a satellite image of Mississippi River under normal flow conditions, and then during a flood that occurred in spring of 2011. The inundation area is incredible during these floods. And just this past year in 2019, the length of time that these floods lasted shattered records from the 1920s, for example. Here's another picture. You can see some of these homes underwater. And experts agree that 2019 in particular was the most damaging flood in about 25 years. So we're really in a new generation of Mississippi River crests that really only bear passing resemblance to floods of the past. We're using climate models to try to understand how these flooding events will change in the future. And in particular, if we look at sort of historical discharge rates and compare them to projected discharge, some climate models show decreased discharge and some show increased discharge. So we're trying to figure out what are the physics and the hydrology controlling these floods, and how might we better improve this disagreement between climate model simulations. I'm working with other geomorphologists in my department to look at changes in the peak and discharge or the river flow on the Mississippi River. This purple line represents that business as usual, we don't get our act together scenario. And what we're seeing is that essentially the discharge increases to dramatically higher levels by the end of the 21st century in these carbon forcing scenarios. This bottom curve shows in red and in blue the difference between carbon mitigation or a lower CO2 forcing scenario and that business as usual, we do nothing scenario. And critically, the design infrastructure for major floods on the Mississippi is exceeded in the scenario where we do not curb our carbon emissions. The choice between mitigation is the difference between catastrophic infrastructure failure and flood control. So these choices mean a lot. We must focus our conversation towards solutions to these problems, and we must train our students to find solutions and demand solutions-oriented dialogue from our elected leaders. The time to talk about the science has long passed. I am so lucky to work at Rice, where I should have the ability to collaborate with social scientists and humanists and engineers who understand that this is going to be an all hands on deck problem. We desperately need interdisciplinary collaboration to solve the myriad issues posed by climate change. I do a lot of work with the Girl Scouts, and I always challenge them to think of solutions. Here are just a few that they've come up with, and they, on their own, divided the solutions into policy, individual, and private sector. I think that the next generation has a lot to add in terms of thinking creatively about solutions. Finally, I'll leave you with one more thought. Part of my research focuses on the past and how Earth has changed in the past. This is our temperature history, and I'd like to contextualize human evolution on this graph. So this graph is temperature changes on Earth going back 500 million years. So for example, here's 60 million years ago, where our friends, the dinosaurs, were happily roaming Earth. It was quite a bit hotter then, since they were massive reptiles. And if we zoom into about 2 million years ago, we can place the evolution of hominins on this graph. And what I want you to notice is that we have evolved in a relatively cold period on the planet. This temperature line shows what happens if we have substantial reduction of emissions. We're crossing Earth's temperature curve about 10 million years ago in that scenario. In a business as usual scenario, AKA we do nothing, we're crossing the graph during the time when dinosaurs were thriving on Earth. So this is a serious problem. We are pushing the planet to temperatures that are not conducive to human life. We have become a geologic force, and we have the power to control our own environment and our own future. So thank you very much for your attention, and I look forward to answering all of your questions. Thanks.
Thank you, Sylvia. Up next, we have Andrea Ballestero. She is an associate professor of anthropology here at Rice, and she's also the founder and director of the Ethnography Studio, which I just learned about from her, and I'm very intrigued by. So welcome, Andrea.
Thank you so much. It's really wonderful to be here with all of you, and let me share my screen. Okay, so it's wonderful. You're going to see there's many intersections between what I'm going to talk about and the work that we just heard about, which is really important and fascinating. So I'm going to be talking about aquifers today. And first, I'm going to tell you a little bit about my previous work and show you how I got to think about aquifers. So for a long time, I've been really interested in the question of how water acquires political and social meaning. And so I did work in Costa Rica and Brazil, working with activists and government officials that were invested in the idea of the human right to water. And my interest was in tracking exactly what that meant. So once people assumed and accepted and embraced the idea that water should be a human right, how does that general idea translate into specific measures in specific countries and according to the specific histories that people have around the world, which vary widely? So out of that work, I wrote a book that I'm going to share with you. And one of the reasons why I'm sharing it's because the book is open access. So you can download it for free in this address that we have here. And I will put the address on the chat later on. But if you're curious, you can go there and see more of the answers that I found to this question of how a human right becomes something concrete in the world. While doing that work, I started hearing a lot from my interlocutors about aquifers, which was something that people in Costa Rica, particularly where I'm from, had not been thinking about very much historically. And that's how I moved into this question of subterranean water worlds. And that's where I want to take you today. So, shaped by the legacy of geological thinking that was globalized starting in the at least 17th century, popular ideas of the underground tend to privilege two figures, the mine and the cave. On the one hand, we have the mine that draws our senses to the physical challenges of extracting materials such as oil, coal, and gold from below the surface. The mine also reminds us of the massive global endeavors that have been launched on the basis of environmental degradation and including really exploitative forms of labor around the world, so that we can extract materials or minerals and turn them into commodities that end up helping people decorate their bodies, build microchips, commit to each other in monogamous relations, or even pass on the spirits of the ancestors. On the other hand, we have the cave, which have very different historical charge. The cave mystifies our imagination by creating the possibility of hollowed out space. The cave offers us a repository for tracing the history of humanity, the deep history of humanity, and it's also imagined as a site to return to origins. In a way, they inspire something that we can call a geological proprioception, that is a geological way of orienting our bodies in space. So the mine and the cave come together as prominent figures in this era that Sylvia was talking about, in which we have been extracting resources really intensively out of the earth. And yet, while these figures have dominated our imagination, there is another subterranean figure that increasingly is capturing our planetary imagination. Hydrologists call this figure an aquifer, but I tend to think about it with hydrogeologists from Costa Rica, with whom I've been conducting research, who have described it to me as a saturated sponge. Aquifers for them are dynamic architectures, sucking and seeping, swelling and shrinking, absorbing and oozing. In the past decade, aquifers have moved from being a concern of specialized government officials or well drilling companies into a larger concern for people in Costa Rica. It is not surprising that this is the case. We know that in the 21st century, aquifers are becoming crucial for our survival. For example, we now know that 99% of the world's accessible fresh water sits underground. We know that half of the world population drinks water that comes from under the surface, and that at least 40% of all irrigated agriculture depends on underground water or groundwater. But despite this newly gained prominence, aquifers remain somewhat mysterious figures. They seem unremarkable. We don't think very much about their form until pollution or drought, which we are experiencing more and more, require us to stop to think about their form. And then we realize that they are kinds of riddles or kinds of puzzles. They ask us to think about water and stone together, inseparably, but also in constant movement. So aquifers in reality are not what you see in this map, this flat, one-dimensional thing. They are the movement that the encounter of water and rock makes possible. So privileging movement, the difficult and never frictionless encounter between water and stone, tends to confound our capacity to disassociate figure and ground, or to separate figure and ground. For example, take a look at this hydrogeologic profile of a particular region in Costa Rica. When you see this image over here, the first question that I would ask you is, what is the aquifer here? If you focus on the stone comes forward as a figure and the water recedes. If you focus on the water, the opposite happens. And so how do we take into consideration this unique characteristic of aquifers in the ways in which we relate to the environment. To do so, I've been working with people in Costa Rica, particularly with hydrogeologists in Costa Rica that work for the National Groundwater Agency. And with them, I've been learning about the efforts that they're making to convey this idea of what aquifers are, how they work, and what their shape is to the general public. And one of the ways in which they're doing this is through models. And you heard about certain models from Sylvia. Those models are also used by my colleagues, quantitative models, mathematical models. But I became really interested in another kind of model, a model that shares more maybe with the arts, or maybe a kind of model that you sometimes see when you go to the doctor and they have a replica of maybe an organ or some part of your body. I first saw this model as I was talking to Jorge, one of the hydrogeologists that I work with in Costa Rica. He started explaining how this model that he takes to community fairs and to schools has an amazing capacity to draw people, to pull people's attention. And he uses this model to help people think about the underground beyond caves and mines. He tells people stories. He narrates what happens above the ground by telling people, for instance, somebody has a well here, they're extracting water, but what happens is that in that substrate there is a pollution plume, and that plume ends up being pulled by the neighbor who's also extracting water because it's time to, say, cook lunch, and they have to turn their pump on. So what I'm really interested in the ways in which this kind of model helps us make sense of the world around us. So you can see how this model pulls audiences and brings many, many different kinds of residents into the question of how to imagine and see worlds that sit under the surface. So in this sense, this model opens up what we take or what we imagined was a mysterious space that is often associated with darkness, the unknown, and even the afterlife. And I'm speaking of the underground here. So perhaps rather than thinking about subsurface formations as the grounds for extractive mines or hollowed out caves, we can begin to think with Costa Rican hydrogeologists and with their environmental fair attendees. They invite us to think of subterranean space as a force-filled space of push and pull. Maybe we could surrender our eyes to the forces that draw political will and bodies in these directions that we often ignore. In this sense, this model allows us to witness something that we are not supposed to see, neither a mine nor a cave. Even though the underground remains obscure, intractable, you feel as if you have made some sense of it after being exposed to this model. You feel that you know something, not because the pieces are teased apart, water on one side and rock on the other. Rather, this model allows us to keep them entangled, to think stone and water together. The power of the model, as it is used in environmental fairs to understand fluid mechanics, is not to disaggregate its components. Rather, its power it's that it replicates an effect. It focuses our attention by making accessible an insurmountable mystery, the simultaneity of movement and fixity. So my invitation for all of us today is to recognize that aquifers are choreographies of water, rock, everyday activities, fears about the future, and stories about what is possible. Our responsibility is to stop reproducing and thinking them, stop reproducing the idea that makes us think about them as water quantities just waiting to be extracted. And as you sit here, or as you sit there, perhaps stand there listening to this talk, think about your feet. Now think beneath your feet and beyond your feet, downwards, and picture the lively worlds that lie under the surface. And ask yourself, how is it that we are all responsible for parts of the world that you cannot directly access or see? Thank you very much.
Thank you so much, Andrea. So next up we have Joseph Campana. He is the Alan Dugald McKillop Professor of English here at Rice and the director of the Center for Environmental Studies. And he was also one of my professors when I was an undergrad here. So I am so excited to have him here today. Welcome, Joe.
Thanks so much. So I can't say that makes me feel super old, but it does make me feel a little old. I've been around long enough to have fantastic students sort of come back, and in this case, like Kate, work with alumni affairs and everything here at Rice. Hi everyone, I'm so pleased to be here to talk to you today, and I feel lucky to get to present with my extraordinary colleagues, Sylvia Dee and Andrea Ballestero. I wanted to talk to you today a little bit about me and my work and what I do around the environment. I am a poet. I'm a scholar of the literature and culture of the era of Shakespeare. And sometimes I have people ask me the question, well, what does that have to do with anything to do with the environment? Poets have been reflecting on the questions we ask around environment and ecology for literally thousands of years. And it's also the case that I could say that I'm a scholar of the era of Shakespeare, or I could say I'm a scholar of the literature and culture of the era of the Little Ice Age, which you saw on one of Sylvia's slides, an era in which people were intensely aware of what we call now climate change, of environmental degradation, of ecological imbalance. And they were thinking about it in a lot of ways at a time too when disciplines were not as far apart as they sometimes are now. So if anything that I talk about today, I'd like to say two things are really important, and they came out really beautifully in both of the previous talks. Longer histories are important. They help us actually understand the problems we're having now in 2020, even if they seem remote, and they therefore help us get to solutions, right? Understanding and articulating problems gets us to those solutions Sylvia was talking about. And secondly, and this is also to echo what both of my colleagues have already said, the solutions, both the way we articulate problems and the way we think about solutions, has to do with understanding our problems as needing, as Sylvia put it, all hands on deck. We need the resources of all the disciplines to work on problems of such sort of scale and intensity as we're contemplating right now. I wanted to pick one for today that I think about both in my research and my teaching, that problem is the problem of waste. I'll say a little bit about that and then just end with a few remarks about the Center for Environmental Studies and some things that Rice faculty and students get up to in that sort of part. So I'm going to share my screen now. There we go. And I think everyone can see that. I hope. Yes. So waste, we think of it as it's something that's ubiquitous. It's something that is seems to be unavoidable, and it's something that we think about it as a problem. One way of talking about the problem of waste is everywhere. It is all around us, and as we sort of, and we are part of it, and we sometimes think of ourselves as sort of very related to waste. That we can think about in a lot of ways. I've been tracking some of this just environmental journalism reporting on certain questions lately. Where are we finding plastics, for instance? Oh, the answer would be everywhere. And these stories, which, especially for those of us who don't work directly in science and engineering, might suddenly be really taken aback to find that there is plastic in the Mariana Trench. There is plastic in the Arctic and the Antarctic. It's everywhere. And when we start thinking about microplastics, that gets a little, even to me, sort of more intense as we think, where do microplastics, those sort of incredibly tiny, sometimes not even visible to the human eye, shards of the plastics that we use, where do they show up? Oh, in human organs and in our soil, right? The problem of waste seems to be that it's ubiquitous in a certain way. Well, there's also another problem in a kind of field that's in kind of increasing in its sort of attention to the various kinds of waste that we need to be thinking about together. And often it's put that this is the problem of away. We think of waste as that which we can simply send away from us. We put it in our bins, it goes away. Of course, what we've already learned is, well, it doesn't exactly go away, right? We find it is pervasive and it's sort of everywhere. But we also find that away, when we even do get it away from us, it's a whole nother kind of problem. There's an incredibly complex geopolitics of waste. And so reporting started a good couple years ago. And this problem was already sort of present and just less reported on, about the extent to which our whole systems for dealing with waste and recycling are fairly broken, because they involve sending waste from certain nations to certain other nations. And the spectacle of of sort of poorer nations actually sorting through the trash of wealthier nations, it is something that you can encounter in your travels if you sort of travel around the world. And so there's a kind of an intensity to that. If we do succeed in sending waste away from us, which we don't really ever get to do, it creates a whole other set of problems. And the idea that a whole economies elsewhere are organized around treating the waste of wealthy nations, that is a more than complex proposition. And as that sort of system of recycling has been breaking down, nations refusing to accept the waste of sort of wealthier, mostly Western nations, that's something that sort of brought attention to the intensity of the problem. Um, Waste is something that we try to think about and be more conscious of. There is a whole literature, almost a kind of a self-help literature of reducing, right, sort of coming to a kind of sustainable or plastic-free life, right? It's something that we think about very intensely. Um, and we have to think about it intensely because there are moments when it's very hard to avoid. Any of us who have ourselves or our loved ones have experienced and needed intense medical care, it's hard to wish away the plastics that help keep some of our loved ones or ourselves alive, right? And so medical waste is a whole nother category, both something that's very disturbing as we see it sort of piling up, as we wonder how to deal with it, but also as we try to imagine medical treatment without it. And think about that in our current moment. One of the kind of most sort of chilling things that we see lately in a moment of COVID are these masks everywhere, right? Occasioning many different kinds of reflection. And this is one of many images hitting the media of late about that collision of something that feels very necessary at a time of pandemic. And yet, here we are, right? What kinds of masks are we wearing? Where do they end up? And are they just like the detritus on the edge of a road or a street as elsewhere? Waste is everywhere. We try to send it away, and either that creates problems or the attempt to send it away tricks us into thinking that we can kind of be uninvolved from it. We can live sort of clean and clear in a way. Dare to dream, right, about that. Sometimes to think about waste, and there are many versions of it, we really need our colleagues in the sciences and engineering, and I've been really interested as a kind of completely sort of uneducated sort of person thinking about some of the things people have been doing, these sort of bacteria, plastic-eating bacteria. There's been a lot of reporting on this lately. We absolutely need new technological and scientific interventions that help us deal with it. But waste is a certain kind of problem with so many angles to it. We need the work of others and many disciplines to think about it. Waste is, and I won't read through all of this, but if we try to define what waste is, we've been mostly talking about the kind of trash, rubbish, detritus version of it, objects, right, and how they sort of work out. But it's also something that has to do with how we understand value. We value certain things by calling them not waste and by devaluing other things that we call waste. It has to do with how we understand dissolution, the vulnerability of bodies, right? It has to do with how we understand consumption, the creation of order. And I put up a little sort of note. A lot of people who write about waste right now actually misquote Mary Douglas. She has sort of that famous moment in that kind of iconic text, purity and danger, dirt is matter out of place. I find it's actually quoted with waste substituted. And you can kind of understand, even as it's the thing that we think we're pushing away from us, it creates a sense of system and order in so doing. Now, as someone who thinks about, in my scholarly work, the 16th and 17th centuries of sort of England and Europe, I've also gotten really interested in some of the more sort of chilling aspects of waste that have to do with how we think about land. Waste is a way of thinking about how we use things, what can be used, what should be used, and very much about land use. Now, sometimes that's, from our point of view, something that's overused, like an industrial wasteland, right? On the other hand, that term has been used very differently historically and in ways worth thinking about. More recently, people have talked, and there's some really fine work about this term wastelanding that's becoming very sort of useful lately, the intentional ruination of land for particular purposes. But it's also a term that is used to describe not just land, but also people who are described as excess, idle, or useless. That's one thing if we sort of make jokes amongst ourselves about watching trashy television or behaving in a trashy manner in a kind of fun way that we joke with ourselves and our friends. It's another thing when people are designated waste, right? And we say that all the time. And that is also not just those people who are sorting through wealthy Western nations' waste, right, in their own countries. I found myself thinking about this partly too, because looking at the sort of materials of the 16th century, the era in which pamphlets are being written, trying to promote the colonization of Virginia at a moment when England is not yet the great sort of empire that it becomes later, there's a sort of chilling way in which all of these things start to interact with one another. One of the justifications, one of the ways of advocating for the settling of Virginia was, and this is a sort of quote from 1585, that the great waste woods there of oak, cedar, pine, walnuts, and sundry other sorts, many of our waste people may be employed, right? Just to sort of translate this a little bit, though it's in sort of fairly understandable kind of contemporary English, waste was a term that was used not just for ruined landscapes, but landscapes that had not yet been put to proper use. Waste wilderness or waste woods should be submitted to agriculture so that that land would produce useful things, and so that you could send the excess people at a time when England felt it was overpopulated, when the city of London felt very overpopulated. The excess people who were idle, who did not have work, could be shipped off to some other land to make so that they would be made useful, and so that that land would be made useful, right? So a complex series of attitudes start to interact around this term waste. It involves land, it involves people, right? And it involves what we assume is the value, right, of both people and land, and what should and shouldn't be used. It's for reasons like this where these different ideas about what waste is start to intersect, that starts to explain why we also need a range of other people to help us think through these issues. We need historians, people who study religion and literature. And I should also say, if we want to understand this phenomenon, it's not just about picking up something on the side of the road, it's understanding a range of issues intersecting through that term. And this is also where I have to say a whole field has emerged called discard studies, primarily, to my mind, really originated and sort of enhanced in anthropology and sociology, and sort of a lot of folk in the humanities have been following along. And we need the resources of people thinking about these different ways of understanding waste and the intersections of the problems that arise. From my point of view, too, we also need artists. Artists who help us sort of think and crystallize sort of patterns of behavior. We've worked closely with an artist named Fabrice Montero. We were actually hoping for a spring exhibition of his works. He's made a series of stunning, complex works called Prophecies, where he imagines what it is that emerges from and is built out of our relationship to waste. And he does so in sort of different places around the world. And in fact, we commissioned a sort of new image from him that he shot in West Texas, in Eagle Pass, which we really want to kind of unveil in an exhibition sometime next year when we can, right? Artists who help crystallize the idea that we're constantly building with and out of waste, right? And that we have to think about it more carefully than we often do. I've also worked with another artist, a kind of team of artists, Marina Zerko and Sarah Rothberg, who also inspired something that I've done with my students in ENST 100, the core environmental studies class. They did a project called Immortal Plastics. One of the things that they wanted to do is encourage us to just be more reflective about our relationship to plastics and waste. So at Brooklyn Street Fair, they did these assessments where people could bring, this sort of could consider what they had on their persons, and they would be inventoried and given an equivalent in plastic pellets of what they had with them, right? A lot of work around the environment is really about raising consciousness and awareness and bringing attention to things that are easy to sort of pass by in our everyday lives. They also had these wonderful sort of petrochemical plastics assessment forms, which I used in ENST 100 with my students. I asked them to kind of go through that exercise and think through their relationship. And boy, did they write a lot also about the masks they were seeing and the kind of different forms of waste sort of that are becoming more common in the moment that we're in right now, right? And so and then this led to really wonderful conversations with these students. And so I also find that much of this sort of work in the arts, it's about modeling, it's about thinking and feeling differently, and it also sort of sets up extraordinary conversations, again, that bring our attention to things that are just easy to pass by as we try to send things away from ourselves, right? I just wanted to close very quickly by saying a little bit about the Center for Environmental Studies before sort of we open things up for what I'm sure will be a really wonderful conversation. I've been really fortunate to direct that this last year or two. We're located in the schools of humanities and architecture. We get to work with extraordinary colleagues across the schools, but we particularly focus on the humanities, arts, architecture, and interpretive social sciences. I've got some links embedded here, and I just wanted to say we have a lot of activity. We govern the environmental studies minor, which a number of a growing number of students participate in, and they take classes across the sciences, social sciences, humanities, and architecture. And we also have a relatively new series. I might put some links up in the chat in a second. That's also available to all of you. It's a free series. It's called Planet Now. They're webinars about sort of focused on conversations in environmental studies. We had a wonderful one this week on Green New Deals and kind of in the pre-election moment. A really interesting one earlier in the semester on the urban heat island effect with Professor Ladd Keith from the University of Arizona, which relates to some of the things Sylvia was talking about. But the most important thing that we can do, it seems to me, is to stay in conversation. We require the knowledge and the wisdom of many people in many fields, and to harness that, we have to stay in conversation with one another. So a lot of the practice of thinking about the environment is a practice of conversation. So that's the conversation I really love to have, and I'm looking forward to having right now with all of you. Thanks very much.
Great, thank you. Thank you to all of our panelists. I know that Sylvia's got to hop off. She's a busy woman today. But you have also been really amazing in the Q&A, Sylvia, just answering all these questions. But I wanted to see if there was anything you wanted to mention here that is from the Q&A that you just wanted to speak more about.
I don't necessarily think so. I would direct everybody to the Q&A. I put some links and materials online if anybody wants my slides, for example. But there's also there was a great question about what does RCP mean in the Q&A. Representative concentration pathways are different economic models for how much CO2 we emit to the atmosphere over the next several decades. So I put some information about those there. But I'd also be happy to answer any more questions we have right now.
Perfect, thank you. So I've got one here for Andrea. To what extent can aquifers completely replenish after they have been completely drained?
Thank you. So not all aquifers are made equal, is how I would begin. There's certain aquifers. So the age of aquifers ranges in places like Costa Rica. They could be, the water could be maybe a few months old, to other parts of the world in which the aquifers, the deeper aquifers, are millions of years old. So for each of those, you can pose the exact same question, and you will find that a good number of them, particularly the deep aquifers or the aquifers that are confined, once they are dried out, as you put it, or once all of the water is extracted, there's no way in which they can be replenished unless there is some form of artificial insertion of water, which is a practice that in some parts of the world has a robust history, but yet it's a very risky practice, in part because one of the amazing things about aquifers is that we know very little about them. We know very little about their actual form, and we know very little about the ways in which masses of water connect to each other under the surface. And part of the reason why we know so little is that it is extremely expensive to do the research, to drill all of the wells that are necessary to know in detail where the borders of an aquifer are. And so the succinct answer is it depends. And even in the cases where you can replenish an aquifer, you're running the risk of inserting pollutants in the underground and then allowing for those pollutants to spread around and actually making more of the water underground inaccessible because of an issue of quality. So you have to ask first, what kind of aquifer are we thinking about to answer that question?
So I guess I wanted to hear a little bit more from each of y'all about how y'all collaborate across departments and how the Center for Environmental Studies has been going and just what that looks like.
I'll just say very quickly, so we've just sort of kind of renamed ourselves in the last year or two, and actually we're the recipient of earlier efforts. In 2002, the Center for the Study of Environment and Society was founded by a biochemist and a literature professor, right? And so the kind of conversations, and that also led to the founding of the Environmental Studies program, which now has its minor, right? And in some ways, that there have been different versions of these collaborations for years. I think what we have to do constantly, we invoke interdisciplinarity and multidisciplinarity all the time. They're both very important. They take time and they take some patience. So being in the habit of doing it regularly is really important. With Sylvia in the last year or two, I've been in some conversations with colleagues across the university about what Rice ought to be doing around its environment, and she can say more about some of the efforts that a previous sort of group, the EnviroFact group, has been doing to understand just how many faculty actually do work that is identified around the environment. So some of it's just about knowing one another and then being in conversation, and then bringing it together in sort of sometimes research teams, but also sort of teaching teams. That's the kind of work we have to constantly be doing. And so and again, it's one of the really big pleasures. It can be complicated and slow sometimes. We also need disciplines that function really well on their own. There's a reason disciplines are merged, but we also have to figure out how to be in conversation with one another.
Yeah, thanks, Joe. So I can echo that a bit and follow up on what Joe just said. So we do have a group of faculty and staff who are now organized. It's actually 150 out of the roughly 600 faculty. So 25% of our faculty at Rice identify as environmental researchers. And so it's really not just a critical mass, a 25% mass of researchers who are now putting together activities, and we're collaborating more frequently. One of the critical things that we are hoping to achieve is to form new hubs of collaboration to promote more interdisciplinary conversation. There's a university task force that was appointed that Joe and I were both on last year, and we're hoping that these efforts will come to fruition sometime in the next couple of years. Obviously, support from the alumni is always going to be critical in getting these efforts organized as well. So I'm glad to have the opportunity to share that with you all today.
Just one other thing, excuse me, one other thing really quickly. Some of my view of this has also changed since I've been teaching the core course in environmental studies, which is sort of mind-blowing in a great way. This year it's about 70 students from, if I counted, close enough, 20 to 25 different majors and programs, right? That's fascinating, and a huge number from architecture. And it's a kind of diversity in the classroom that I've not experienced before. It makes for fascinating conversations. Sometimes it makes for difficult conversations. Wait, are we all using these terms in the same ways? Do we all understand these problems in the same ways? And what can we each bring to them? But that's a kind of wonderful challenge. And I have to say, one of the nicest things here as well is a lot of things lately too are really being led by the students. We've introduced new courses in environmental justice, and it was largely out of student demand. And I feel like we're both working on our research and our teaching, but we're also trying to keep up with our students who are of the generation for whom pressing issues about environment or climate are ever more pressing. And that is what the future looks like. We may not sure exactly what it looks like. That's what people are thinking about, and especially the generation of university students right now. So I feel like we're also partly making sure we're kind of keeping up with this generation as well.
I just wanted to add to the conversation that these collaborations are within Rice, but they're also from people at Rice with colleagues outside of the university. And that's one of the really beautiful things about this work, that this need for interdisciplinary conversations is not exclusive to the university realm. I've learned so much from my hydrogeology colleagues in Costa Rica and from scientists all over the world who are very, very interested in the kind of work that we can do from the humanities or social sciences. So I just wanted to put on the table the fact that in addition to our students who also want to establish these connections with colleagues outside of the university, we as researchers are also developing these conversations with people outside of the university.
Amazing. We're getting so many comments thanking y'all for an amazing presentation. So less questions, people just excited that this happened and y'all could come together today. I wanted to hear a little bit, Joe, you sort of read my mind about students and their wants. And I wanted to hear a little bit more about what are the classes that they're taking. I know environmental justice, but what are the big classes that are really drawing in those students?
Yeah, so it's been, again, part of one of the most fascinating parts of this job working with the center is to sort of watch the ENST program grow. We have courses in pretty much every division, students who minor in environmental studies, and it's a separate program, but there's a partly shared curriculum with the environmental science major, which is also where a lot of our students come from in our classes. So we've got classes in civil and environmental engineering. I was just talking with Jim Blackburn about his environmental law class in the spring. Surprisingly to you or not, poetry and law have a lot of interesting things in common. So we had some really interesting chats about that. So environmental law and policy courses that he teaches are very big. Sylvia teaches a fantastic climate science course people take. We've got new courses coming in the sort of cultural and media world of environmental health, taught from the kind of humanities, social sciences. That's a new course that'll start in the spring. Anthropology, we have a really wonderful department of anthropology with tons of courses, Andrea's and courses, obviously, and others. It's pretty much every division, and that's been also a really beautiful thing to see. And our students, the undergraduates, get to take, they take a couple core courses, but then they get to take essentially electives in the different divisions. So they're getting an experience that is multidisciplinary, which is really fantastic.
And Andrea and Sylvia, are y'all seeing more students in your class coming from different backgrounds that haven't been there in the past?
Yeah, so in my Science of Climate Change course, which is a 200 level Earth Science division course, I'm constantly impressed by the diversity of student majors. I have political science majors, I have humanities majors, I have civil engineers as well, and obviously the earth science majors are there, but it's really representing all schools on campus. And I also just wanted to add the number of environmental studies minors and environmental science majors has grown exponentially over the last 5 years or so. So we're seeing incredibly increased demand for these types of courses. We also had an intern compile all of the environmental courses offered at Rice last year, and it was over 100 courses being offered. So it's really incredible what kind of access the students have to this information, and I think it's great.
Absolutely. I remember in my Anthropologies of Nature class, I have had biology majors, ecology and evolutionary biology, engineering, chemistry, the anthropology of water similarly. So it's really a fantastic thing. I mean, well, you all know Rice, you all know how amazing our students are. So it's really a pleasure to have that diversity in the classroom, because it's always like we're really engaged in substantive conversations. It's not a superficial, you stay in your corner, I stay in my corner, we see the environment differently. But it's really getting at the foundations of why we need different approaches. So it's really fantastic. And the ways in which through all of the different classes, there's a diversity of projects that students engage in. So we're well beyond you're just going to get some information. We're doing all sorts of really amazing projects that take students outside of the classroom as well. So it's a really exciting time for this to be happening at Rice.
That is really amazing. I'm loving hearing this. I'm loving that the students are so involved in this and asking for this as well. I think that's such an important sign, and that Rice is responding the way they're responding. Well, I want to thank you, all the panelists, for coming out this morning, or Zooming in this morning, I should say. I think this was a really amazing talk, and thank you so much.
Thanks for organizing this, Kate. I really appreciate it.
Of course.
Thanks very much, and nice to virtually meet all of the attendees.
Yes.
Thank you so much, and have a really good rest of the week.
And for those asking, this video recording will be available in the upcoming week or so, and an email will go out when all the videos from OWL Together are available. So thank you again, and I hope you have a great Wednesday.